program. The program interacts with the operating system, and the operating system gives access to things such as the file system, the GPIOs, the screen, and many other things like communications, for example. So again, without an operating system, the Raspberry Pi is just paperweight. Over the last few years, and as the Raspberry Pi went through its iterations and it became more powerful, more and more operating systems started becoming available for the Raspberry Pi. When you go to the raspberrypi.org downloads page, you'll see that there's quite a few operating systems available through the raspberrypi.org website, and there's many more that you can find from third-party websites as well. So I'll lose count of how many there are out there. The operating system that the Raspberry Pi Foundation supports and keeps current and looked after is Raspbian. So you can see here, Raspbian is the officially supported Raspberry Pi operating system. There's a version of the Raspberry Pi operating system that you can actually install on your computer, a Mac or PC computer, and you can get the same educational applications, programming languages, and so on that are available on Raspbian for the Raspberry Pi, but for your computer. So if you go to Raspberry Pi desktop here, you'll see that this is an identical Raspbian, but that contains the exact same applications that you can run on a full computer, whether it's Mac or PC. That's quite interesting as well. So in order to use the applications that come with Raspbian, you don't need a Raspberry Pi. You can just use your computer. The only thing that you don't get, of course, is access to the GPIOs and to the specialized hardware that comes with the Raspberry Pi, like the camera, for example, and other hats. Now, apart from that, I'm going to come back to Raspbian in a minute. I also wanted to mention Noobs. So what Noobs is an operating system installer for people that are absolutely new to the Raspberry Pi and that don't want to deal with the nuances of actually burning a operating system image on an SD card, which anyway is very easy, as I'm going to show you very soon. Very often Raspberry Pis are sold with SD cards that contain Noobs. And what the user can do is they can connect it to a screen and a keyboard, start the Raspberry Pi, and then Noobs is going to boot. And through Noobs, the user will be able to choose which of several operating systems they would like to use. And then Noobs will go fetch the necessary files and install the operating system that the user has chosen on the same SD card. So through Noobs, you avoid the step of having to burn the image of your selected operating system on the SD card and then to configure it. Of course, this is useful if you do get Noobs installed on the SD card that comes with a newly purchased Raspberry Pi. If you don't have it, then you can still download it from here and burn it yourself on an SD card, but that defeats the purpose. And I think in that case, you're better off to just go and install Raspbian, which is what we'll be doing soon. Now, another thing that I'd like you to know about is that there's a bunch of other operating systems available, as you can see here. So there's OSs like Ubuntu Mat and Snappy Ubuntu Core and Windows 10 IoT Core and so on. And those, let's say if we go to, let's say Ubuntu Mat, what this does is a flavor of the actual Ubuntu Mat operating system, which is very popular among Linux users, and the exact same setup can be available on your Raspberry Pi 3. So this is quite heavy operating system in terms of resources, so you need a faster Raspberry Pi 3, whereas with the Raspbian operating system you can run it on earlier Raspberry Pis like the Raspberry Pi 2, for example. All of these operating systems just emphasize a particular aspect of an operating system. So for example, the Windows 10 IoT Core emphasizes the use of the Windows IoT infrastructure from your Raspberry Pi. So again, depending on what your objectives are, you can choose an operating system to match those objectives. Another thing that I want to mention is an operating system that is not listed here is Minibian. The first version of Raspberry Pi full stack that I released in 2015 actually featured Minibian instead of Raspbian, because back then there was no light version of Raspbian. And just hold on to that thought, I'm going to explain what light version is. So I decided to use Minibian back then in 2015, and then an update of Minibian came out in 2016 because it was the smallest possible version of Raspbian that I could find. And because I wanted to build a minimal web application stack on my Raspberry Pi, I was looking for the smallest possible footprint version of Raspbian, and Minibian was that version. By minimal, I mean that the operating system, Raspbian in this case, comes with a lot of components that are not really necessary when we just want to build a web application. By using the full version of the operating system, we are wasting a lot of space that can be better used for things such as logging and database files. So Minibian threw away all of the components in Raspbian that were not useful. For example, the graphical user interface, email and browser applications and things like that, and only kept the bare minimal. And from the bare minimal, you'll be able to build up by installing the absolutely necessary components for your web application and the web application stack and nothing else. So that's why back in 2015, I decided to use Minibian. Now fast forward a few years and we go into Raspbian. You'll notice that there is a version of Raspbian called Raspbian Lite. So the Raspbian Lite version is the equivalent of Minibian from a few years ago. So again, the difference between Raspbian Lite and Raspbian Desktop is that the Lite version doesn't have any of the applications and the graphical user interface component that are necessary for an operating system that is meant to be executed and to be used on the desktop. All of those components are thrown out and only the app The kind of application that we'll be building involves a Raspberry Pi connected to a sensor that runs a web application that we can access remotely from another computer. For this kind of application, it's not necessary to have a monitor, a keyboard, and a mouse connected to the Raspberry Pi. It would be totally unnecessary and a waste of hardware as well. The idea is that the application, the Raspberry Pi with its sensors, will be placed at a location that we want to take measurements from and essentially forgotten about whenever we want to access the database perhaps, or get the current readings or historical readings from our application. Then we want to use a web browser from whichever computer we happen to be sitting in front of at the time and then access it that way. we wouldn't be walking over to the computer, turning on the monitor, and then checking out the readings. So the kind of operating system that gives us the minimal infrastructure in order to build an application like that is called headless. The main characteristic of a headless operating system is that there is no monitor, mouse, or keyboard attached to it. Essentially, we don't interact with a headless operating system directly, but instead we interact with such a operating system via a remote connection. So we use typically an SSH type of connection or remote desktop or something like that. And in this course, I'll be showing you how to use Secure Shell or SSH to do all the kind of work that we need to do in order to set it up, upload files, modify or edit files, and so on. A headless operating system is best for server type or remote type of applications, whereas a GUI type of operating system is of course best for running desktop applications where we need a monitor and a mouse and a keyboard to interact with the computer. Another aspect of a headless OS that I really like is that because there are far less components that make up the operating system, there are a lot fewer things that can go wrong. That gives us a more robust operating system with improved reliability. And also, of course, there's fewer things to update, so we don't have to worry too much about updating it. And there's also improved security because we don't have the typical applications that are often taken advantage of by hackers. For example, hackers taking advantage of vulnerabilities in browsers and JavaScript or email clients and so on. So another benefit of a headless operating system is that because there are no graphics to be worrying about, because there are no graphics at all, we don't have to allocate any of the Raspberry Pi's limited RAM to the video. We can allocate all of the available RAM. So on a Raspberry Pi 3, that's 1 gigabyte, we can allocate all of it to our application and to the operating system itself instead of the video, as we need to do, especially if we are running graphics intensive applications like playing video on screen and things of that sort. These things require more graphics RAM. So we get additional boost in performance by allocating more RAM to our application. I'll show you how to do that as well. These are the reasons, if I want to narrow this down a bit, these are the reasons why I chose to go with a light version of Raspbian instead of the full version of Raspbian. If you only have one Raspberry Pi and right now you are using that Raspberry Pi for other things as well, then everything that I'm about to show you will also work perfectly well on the full version of Raspbian. So feel free to continue like that as well. But if you can spare a Raspberry Pi in order to go headless, then go ahead and use the light version of Raspbian. Now, one more thing that I need to emphasize here before moving on is that when we work with the headless version of an operating system, then we are committed to be working only on the command line. There is no point and click interface. Everything will be done in the command line. And that's what the command line looks like, as we'll be going through the building of our application in this course. If you're not familiar with the command line, don't worry, as long as you can type, you will be able to learn fairly quickly the few basic instructions and commands that you need to know in order to navigate an operating system in headless mode completely and only via the command line. You'll be able to get used to this very quickly, and by the end of the course, you'll be very comfortable working with the command line. One last thing before we move on. Although we'll be using the command line exclusively to interact with Raspbian running on our Raspberry Pi, on our host computer, which of course is running a full graphical user interface operating system, could be Windows or macOS or Debian Linux, on that operating system, we do have all the convenient graphical tools to use to build our application. So, for example, we'll be using a graphical text editor. We'll be using Secure We are going to download the light version of the Raspbian operating system and then copy the image onto the SD card that we'll be using with our Raspberry Pi. To do that, we'll go into raspberrypi.org/downloads and then click on the Raspbian operating system logo. That will take us to the page where we've got the option of downloading either the desktop version, the full version of Raspbian with the GUI elements, or the light version. So we're going to go ahead and click on the download button to download this. It's a process that takes a few minutes, maybe a few hours, depending on the speed of your internet at your location. In my case, I'm going to actually stop the download because I downloaded the image a bit earlier, and here it is. Actually, I'll remove that, and here it is. It comes as a zip file. The zip file is an archive that contains the compressed version of the image that we want to put onto the SD card. So first we need to expand it, and once that process is complete, you'll see that you've got a file that's got the IMG extension. So this is the image file that we want to copy onto the SD card. When it comes to transferring this image file onto the SD card, there's a few different ways by which you can do that. Different utilities allow you to do this sort of thing, or you can also do it on the command line. But it seems like the easiest these days, the easiest way to go about this is to use the Etcher app. The nice thing about this is that it's cross-platform compatible, so you can download a version for the Mac, for Windows, or for Linux, and it works exactly the same way on all three operating systems. So download the version of Etcher for your operating system and then start the application, and this is what you have. Just clean up my desktop, and this is what you have. Now the Raspberry Pi requires a mini SD card that goes into the connector at the bottom of the board. So I'll be using an SD card that is 16 gigabytes of size, and I've also done the same thing, that I've tested the process with an 8 gigabyte SD card on a Raspberry Pi 2, and it worked with no problem at all. I'm going to have a lot of empty space on this card, so that SD card connects onto the connector, the SD card connector on the Raspberry Pi like that, spring loaded. You push it in to lock it in, and when you want to remove it, just push it in again to unlock the mechanism and take it out. My computer has got an SD card slot right there, and of course I will need to use an adapter for this SD card, and a normal SD to micro SD adapter. So here it is. Use the adapter to be able to then insert the SD card into my computer's SD card slot. So with the SD card inserted into my computer, the next thing to do is to select the image. So go into downloads, and I want to pick the image with the IMG extension. Remember, it's the light version, and click open. If you have more than one SD card readers and you've got multiple SD cards inserted, you can click on the change button and select the one that you actually want to put the image on. So yes, I do accept to use my 15.9 gigabyte SD card, and hit continue. So that I've got my SD card selected. I hit flash. I need to provide my password, hit OK, and then the process of copying the image onto the SD card will begin. It's going to take about a minute. You can see the estimated time to complete this process. So Etcher will flash the image onto the SD card and then verify it as well to make sure that the copying was correct. Let's fast forward at this point. Great. And the flashing is completed. As Etcher completed this process, it also ejected the SD card so that it's safe to remove. So I'm going to remove it for now. Now, before I actually plug the SD card into my Raspberry Pi, there's a couple of things that I'd like to do. Because we are going to be using the Raspberry Pi in headless mode, which means no monitor and no keyboard attached to it, we need a way to be able to remotely access the Raspberry Pi and also to be able to find its IP address. If you're using a Raspberry Pi with integrated Wi-Fi, then you also like to be able to set up Wi-Fi before you actually boot it for the first time. So to recap at this point, before I go ahead to insert the SD card into my Raspberry Pi and boot it for the first time, in the next lecture I'm going to show you how you can enable SSH so that we can connect to it from a desktop computer, and how to set up Wi-Fi for the Raspberry Pi 3. In the previous lecture, we prepared the Raspbian operating system to enable SSH and to connect to the Wi-Fi network if you are using a Raspberry Pi with built-in Wi-Fi capability. So the next thing to do is to insert the SD card to the Raspberry Pi and power it up. As far as power requirements are concerned, the setup that we'll be following in this course will be minimal. We're not driving any external screens, any keyboards or mice, any external Wi-Fi dongles or relays or anything like that. So the power requirements are really minimal. So all I'm doing here is I'll be using a spare USB power supply. This is just a 10-watt power supply, and it's more than enough to provide enough power to my Raspberry Pi. So I'm going to plug it in to a power point. I'm going to insert the SD card into the socket. Then I'm going to connect my Ethernet cable. Since this is an early version Raspberry Pi, it's a Raspberry Pi without integrated Wi-Fi, I'll be keeping this connected to my Ethernet network. And finally, I will apply power. We've got the activity. You can see the green LED starting to blink as the Raspberry Pi is booting up. I'm going to give it a few more seconds for the activity to settle. So the first boot takes a little bit longer. Okay, so there should be enough time, about a minute and a half later, for the boot process to complete. Now the thing we need to figure out is what is the IP address that my network has allocated to this new Raspberry Pi that just became a part of the network. The easiest way to do this is by using a network scanner. Now the thing we need to figure out is what is the IP address that my network has allocated to this new Raspberry Pi that just became a part of the network. The easiest way to do this is by using a network scanner. There's a lot of different network scanners that you can use on Windows, Linux, or the Mac. The one that I use here is called iNet. And what I'll do is hit this button to get the application to scan my network. And then look for the new addition. This is my existing previous Raspberry Pi. This is still running the application from the first version of Raspberry Pi full stack from 3 years ago. Still going strong with Minibian. Let's see where else. And here it is. I think that this is the new Raspberry Pi that we just plugged in. So its IP address is 192.168.111.35. So let's try to connect with this information. So in Raspbian, the root user is disabled for safety, and instead we use the Pi user to log on. To the password for the Pi user is Raspberry. So let's try it out. SSH Pi at 192.168.111.35. The password is Raspberry. And yes, we logged on for the first time. When I log on to a new Raspberry Pi for the first time, I use the raspi-config utility to make some basic configuration changes. So let's run raspi-config. Raspi-config needs to be executed as root. So to do that, I'm going to use the sudo keyword that is going to allow me to execute a program as the root user, and then raspi-config is the name of the utility. So sudo raspi-config. That will take me into the configuration tool. You can change the password, of course. I'm not going to change mine. I'll be using Raspberry as the password for my Pi user. We can have a look at configuration settings. This is another way by which you can change the Wi-Fi settings for your Raspberry Pi 3. You can change the name of the host name of your Raspberry Pi. So I'm going to call it Raspberry Pi FS V2 so that I can easily see it on my network. I'll show you what the effect of this change is in a minute after I do another scan using iNet. So that's network. I'm going to leave localization options as they are. Interfacing options, there's nothing here really to change. We've already set SSH and enabled it. We don't really need any of the others. So I'm going to leave everything else as it is. Overclocking allows you to speed up your Raspberry Pi, which again I'm not going to do. I don't mind my Raspberry Pi running at its factory settings, but some people that want to push the envelope a little bit more in terms of performance may be able to get away by increasing the Raspberry Pi processor CPU speed to a higher number of megahertz or gigahertz. But just be careful when you do that, because you will need to have a power supply that can supply the additional power needed for overclocked settings. So I'm not going to cancel out of this as well. A few advanced options, expand file system, I'm going to enable that. So with by expanding the file system, we get the Raspberry Pi to reconfigure the way that the SD card is set in order to take advantage of all of the available space. When you burnt the image onto the SD card earlier on your computer, only part of the SD card space is used. So now we're going to use the whole lot. Apart from that, I also want to change the memory split, because we don't have an external monitor connected and we're not going to be using any graphics at all. I can actually decrease the amount of RAM given to the GPU to the minimum, like at 16. Can actually make it even less than that, but I'm just thinking that I should allow for some RAM to be given to the graphics processor unit, which is part of the Raspberry Pi's CPU, just in case there is a process that requires the GPU to do a bit of work for it, though I don't think there is any. So I'm just being a bit conservative here. And we don't need anything else here. I'm going to back out that. We can update the configuration tool to its latest version, but I don't need to do that either now. So I'm going to finish in order to get the Raspberry Pi to reboot and apply those changes. So the reboot process is going to take a little bit of time again, maybe a couple of minutes. I'm going to give it a couple of minutes to complete the process and then log back in. You can see the activity LED is almost solid green. It was solid green. It means that there's a lot of activity taking place. Okay, there should be enough time. Okay, let's see if we can log back on. So repeat the same instruction as from earlier and the password. And now you can see that I'm logged on. I've got the new host name for my Raspberry Pi, and we are now ready to move on. In the next and last lecture for this getting started section, I'm going to show you how to enable the root user, because we'll be using root a lot during the remainder of this course. So let's go and do that next. In this lecture, I'll show you a couple of tools that you can use on Windows to be able to both detect the IP address of your new Raspberry Pi and to connect to it using SSH. So for the detection first, there's a lot of network scanners obviously available for Windows. The one that I find very good is and also a free download is called Advanced IP Scanner, and you can download it from this location. So once you download this tool on your computer, you can start it, then simply click on scan, wait for a few seconds for the scan to complete. There is also starting to come in. And down here is the new entries 192, 168, 111, and 35 is the IP address of the new Raspberry Pi. So with this information in hand, you can connect to it using SSH through a little utility called PATI that you can download from this location. So download the installer or the installation file that matches your flavor of Windows, and I've already installed mine here, right there. So all you got to do is make sure that you are in the session tab, type in the IP address that the scanner revealed, make sure that you've selected SSH as the connection type and click on open. And we want to log on as Pi, and the default password is Raspberry. And there you go, we've connected. Now once you are here, the instructions and the